The application from Part 1 runs on your local machine. In this episode, we containerize it and put it on the internet. We write a Dockerfile for the FastAPI service, a Docker Compose file that runs the app, and Chroma as persistent services, an nginx config that handles SSL and streaming correctly, and a deploy script that takes the whole thing live with a single command. The deployment has 3 layers. nginx sits in front and handles incoming traffic on port 443 with SSL. It proxies requests to the FastAPI app running on port 8000 inside the Docker network. The FastAPI app talks to a Chroma service on port 8001, which is not exposed to the internet at all. Chroma data lives on a named Docker volume, so it survives container restarts. Secrets are loaded from a .env file that never gets committed to version control. The Dockerfile uses the slim Python 3.11 base image to keep the container small. We copy the requirements file first and install dependencies before copying the application code. This layer ordering means Docker caches the dependency installation and only reruns it when requirements.txt changes, making rebuilds much faster. We expose port 8000 and start Uvicorn with 2 workers so the service handles concurrent requests. The Docker Compose file defines 2 services. The app service builds from our Dockerfile, loads secrets from the .env file, and depends on Chroma being ready before starting. The Chroma service uses the official Chroma image and mounts the named volume so the vector index persists across deployments. Restart unless stopped means both services come back automatically if the server reboots. The entire stack starts with one command, Docker Compose up. The nginx config listens on port 443 with Let's Encrypt SSL certificates and proxies traffic to FastAPI on localhost port 8000. The 3 streaming critical lines are proxy buffering off, proxy cache off, and XXL buffering set to no. Without these 3 lines, nginx buffers the entire response before forwarding it, and streaming breaks silently. We covered exactly why in episode 17. These settings ensure each SSE token reaches the browser the moment the model produces it. The .env file holds all API keys in the internal Chroma host name. Add .env to your .gitignore before the first commit. A leaked key committed to a public repo gets scraped by automated bots within minutes. The deploy script pulls the latest code, rebuilds the image, and restarts services in detached mode. Set -e exits immediately on any failure. After startup, it calls the health endpoint with curl and exits with failure if it does not return a 200. 2 curl commands confirm the deployment. The health check returns status OK immediately. The streaming endpoint should return tokens one at a time with the no buffer flag. If the full answer appears all at once instead of streaming, the nginx buffering settings are not applied. If the health check fails, inspect the logs with Docker Compose Logs app to find the error. A working streaming response in the terminal means the full stack is live. Look at what you built! From the very first embedding in episode 1 to a live production system with hybrid search, re-ranking, semantic caching, hallucination detection, streaming, agentic loops, graph rag, multimodal retrieval, and full observability. Every technique is running on a real server. This is not a toy. This is a production-grade RAG system that you built line by line. That is the full series. 25 episodes from the first embedding all the way to a live deployed production RAG system. If you made it this far, thank you. Building this series took a lot of work, and I genuinely hope it saved you months of trial and error. If it helped you, please subscribe and share with someone who is building RAG systems. It means more to the channel than you know. I will see you in the next series.